Alright guys, welcome back. So today we're going to be doing an extension of our pixel sorting tutorial from last week. Focus here is going to be adding anisotropic detail, which really just means adding some variation across the image to add more interest. So if we take a look at what we'll be building today, what I mean by anisotropic detail, which by the way just means that or rather, anisotropic means a property, normally of a material, that's different based on which direction from a given point you're measuring, versus isotropic, which is a continuous, consistent measure regardless of direction. So really just meaning an image with some dynamics that change across the image's UV. Tops are great, but I find that working with tops makes it pretty easy to get stuck just purely doing operations that affect the entire image at the same time. Now you can obviously get away from that, but it takes intent because of the way that tops, which are based on GLSL shaders, just naturally operate. So this is something that I wanted to put some thought into because I think it adds a lot of interest. A couple other things that we'll be working with today, just to give a lay of the land. We'll be adding some functionality to look up our sort direction and add these kind of cool, like, snap into focus type effect. We will figure out how to update the resolution based on the input or not. We'll add some additional dynamics using a second texture that will be optionally read in during our update step, and a couple other things that we'll jump into. So to get started, I'm going to grab the pixel sorting top that we left the last tutorial with. So if you guys haven't followed along and created this component, I recommend you do so now. Alternatively, you can head over to my Patreon and grab the project file there. So with that, let's jump in to our pixel sort and get going. So we're not going to be doing a ton of additional programming this time, at least not in GLSL. So I'm going to go through some of the, well, I think the first thing that we want to do, and if we focus on this again just to make things clear, our pixel sort as is lends itself to this very nice smooth gradient. If we hit reset, we can see the evolution happening and watch the sort, and that's pretty cool. But it doesn't really have a lot of dynamics, and it is pretty difficult to use something like this for interactive, audio reactive, dynamic, just a lot more of the motion-based textural stuff is going to be hard to achieve using just the straight pixel sort, because once it's sorted, and there's nothing you can really do after that. So what I like to do to kind of compensate for this and allow some dynamism to be injected is to have a update layer, and that update layer we will read and mix just a little bit from the update layer with our sorted value each frame, and that will allow us to have a much more lively effect. So actually, I want a different image to make it a little bit easier to see the difference, so I'm just going to grab one from my hard drive, but you can certainly use any image that you like. I'll just call this a null update text, and then we'll jump in our GLSL. Now, like I said, we're not going to be doing a ton of programming here, but this is an important part. So first, we'll read in our image with a vec4, we'll call it update text equals to texture std2d inputs, and we want to sample vuv.st, And then what we want to do is just update our image vector using this mix function. And so we'll mix our original image vector with our update texture, and the last value is the mixing coefficient. So with this value set at 0, it's going to be equivalent to just taking the unedited image vector, as we're seeing here. When the value is set to 1, it will be equivalent to taking 100% of the update vector each frame. This should not be 0, actually. This should be 2. There. So now when our mix is set to 1, mix weight is set to 1, it's all our update texture. And we probably want something a little bit closer to 0.01, which will now give us this cool kind of overlay evolution between the two images as the sorting is occurring. Now, one way to add some immediate just kind of differentiation is to drop a noise down. And what we're going to do is use our noise to look up this value. So you could, for example, just use a parameter, right? You update weight. That's not right. Whatever, I can't spell today. You update coefficient like that, and then create this, and then create a parent component parameter, update text weight. And we are going to use this later, so this isn't completely dead. I'll just scroll that over. All right, so we could do this, and this will allow us to, use our parameter, get the update weight going, change some things. Probably want to make the range much lower, 0.02, and then clamp them in at 0. So yeah, we're getting something, but again, this is still isotropic because it is applying the same update weight for every part of the image. So what I want to do instead is use this noise and actually just use the noise, maybe with a null for best practice, Alt-N to create a null. And we want to use that to actually drive our update coefficient. So let me think. We'll do a float, update weight equals, and I'll just copy and paste this, and we're going to want the next input, which in this case is going to be 3. And we just want the R component since it's a float, and then we'll replace our coefficient, our U update coefficient uniform with our texture read. So if I make this a period of something like 4, it's a much more clear what's happening. So you can see that where our, and maybe our exponent is 0. So you can see that where our exponent is 0, or where our values are 0, we are just doing our sort like normal. But where our values are 1, we're actually taking just this pure update text. So this is essentially not sorting at all wherever this texture is coming up white. We don't necessarily want that, but I did want to show you what's going on here. So our noise is going to be 8-bit fixed, so this is just going to be between 0 and 1. We can drop down a threshold, add some softness, and give this an exponent again. Actually, I don't know if we need a threshold. I kind of like it for visual clarity. And so now this update weight, I don't think we need this. Now this update weight is going to be very high, right? And we said that we want our actual update weight to be much lower than the range 0 to 1. And so that's what we're going to do. We're going to take our math and we want to simply multiply our math by our update weight here. And so now update weight is set to 0, so there's nothing happening. Our normal sort, we go up to 0.2. We can see that we are now updating and we're grabbing from this area more from the update texture than we are from this other area. And that is because of our noise and our math here. So that makes it pretty handy. I mean, you can really turn this up and see the effects a little bit more poignantly. It makes it pretty handy, especially when you then start to animate this. Because now our base weight and kind of where we're pulling from the other image is updating every frame. And so that is going to potentially lead to some pretty cool dynamics if we put this update weight lower and allow more evolution to take place. Especially if, again, I drop the exponent so it's a little bit clearer what's happening. We can see, like, especially in this area right now, as the noise is transforming, you can kind of see the sorting happening gradually and just kind of developing and evolving over the image, which is already a way more interesting dynamic than where we started, or sorry, where we ended the last tutorial on. So that's pretty handy. I'm going to leave that as is for now and focus a little bit on our actual update texture, because this is cool, right? And we can see we're kind of starting to flip in between and kind of morph between these two images, which is a very cool effect. I really like it. But we're just pulling from this static update texture right now, and it leaves something to be desired, I think. So turn this exponent up before I forget, so we have some nice, actually I'm going to put a threshold in, and then I'm going to leave softness all the way up, threshold a little bit like this, maybe like that, and then we leave for now. So yes, now we're going to focus on our update texture. So this is going to be, I'm going to full size this for now. This is going to be kind of the main technique for generating a lot of that anisotropic depth. What we're going to do is use a series of matte tops. I'm going to call it like a matte waterfall. And basically use the matte tops to build up this layered textured image. So if we just take a look at a single matte chop for argument, say a constant, we'll call that a red one, and we'll set up a blue one. And then we'll just grab our noise, actually. We can just grab this. So red goes in 1, blue goes in 2, our noise goes in 3. And we'll set this to luminance. And, whoops, well that's not right. Let's take the noise before we multiply it by the math. And we'll throw a threshold in here for good measure. So now we can see what the matte top does. It will simply sample an image or it will sample from one of two images based on a third lookup texture. And that lookup texture can be looked up based on red, green, blue, alpha, average, maximum, and luminance. Luminance is normally what I use. So we're going to use this and build up to a more textured image for us to use in our updates. So to get started, I'm going to rearrange our network a little bit by grabbing some selects. Paste in. So I'm just going to move all of these inputs to select top so that we can straighten out our network. Select vels, select update text, and select base weight. All right, so there we go. Now we can move this over. We can move all this over. Kind of get that off to the side, clean it up a bit, and declutter our workspace. And I'll get rid of these sample mats. Okay, so now we have our image 1. So we'll say image 1 in. I'll add another in. We'll call this image 2 in. And I'll just throw a null in that for best practice. Okay. So now what do we need to do? Now we need to start using mat tops to compose our base image and new image using something. And that something can take a lot of different forms. So we are going to start by just using a noise here. Make the seed something, make it translate. So one thing that I'm going to do now is create a parameter called time on my parent. And this time will be my abs time dot seconds. And then I'm just going to reference the parent parameter time for my translate. With a reference, translate, and then what I can do is do the normal times 0.05 to get us translating a little bit slower. The reason that I want to do it from this main parent component parameter is because we're going to have several noises by the time we're all said and done here, and I want each of them to be able to translate a little bit differently. So for example, if we paste references to each of these two noises, we can multiply this one by 0.05 like we had, and this one we can actually just maybe multiply by 0.06. Again, it's very subtle, but having the noises translate at slightly different rates, I find leads to some cool effects once everything gets added together in the end of our more complex setup. So we see here we're only pulling our image 1 for now, and that's because we need to set our mat to Luma. And now we can see that we're already getting a cool blend. If we go to the noise and change, we can see again using the exponent a little bit more drastically what's going on here. So I like the exponent to be maybe about 0.5 because we do want it to be somewhat sharp in between the two images, but not super like a knife cut edge sharp. So that's mat 1. Let's find actually this update texture and wire that in. And so now the output of this mat is going to be what the update texture is reading in our pixel sort. And turn that off. All right, so cool. Maybe this will be a little bit easier to see. All right, so our update texture, as we can see, is working. And there is some more visual interest, but it's not like terribly crazy. I'm going to turn our update weight up to about 0.1 so we can see more what's going on. And I'm also going to change this transform to something like 0.1 so that we get some more motion. And then finally, I'm going to make the period maybe 2. Maybe bigger than 2, maybe like 2.5. Because we want our variations to be pretty large across the image. We don't really want, you know, like something like this. I mean, maybe you want that. It actually does look kind of cool when you get really small in the period because there's just so much happening. But I tend to like something a little bit larger, like this. And so you can kind of start to see the picture, but where things really get interesting is then when we take another mat. So let's drop down another mat, turn it to Luma. We'll wire the first mat into the top, and then here I'm actually going to select my feedback and wire that in as input 2. Make sure this noise is 8-bit fixed. Copy and paste it, change the seed, maybe change the period like a little bit. Change some of these a little if you want. And wire that in as our mat 2. So now, to see the difference, you have your mat 1 on one side and mat 2 on the right. And so we can see that we're pulling in our feedback in some areas based off of this noise. And when we're not pulling in the feedback, we're pulling in our update texture from the other mat, which is also this one that's moving kind of fluidly between the image 1 and image 2. So I like where it's going. We'll go back to looking at our final image. Wire this into our update texture. And if we flip back between the two of them, you can see the impact, right? It's not huge, it's not crazy, but the change is there. And it does, I think, add some depth and dynamism. So we're gonna add a couple more of these layers and build up to our final effect. So the next layer is, well, I guess it's worth noting before I go on to the next layer. The reason that I like to pull feedback into this is so that we start to have dynamics that emerge from our algorithm that we don't necessarily program 100% consciously. What I mean by that is, once you start having noise tops that are in motion, translating, adding dynamics, layering those kind of offset transformations on top of each other is going to lead to some interesting outputs. And once you start feeding those outputs back into our inputs, especially through the matte network, you're essentially just building a pretty complex feedback loop, and it can start to lead to some pretty cool and unexpected results. So I always try and find a way to drop a feedback and make it a closed loop wherever possible, even if it's something pretty subtle. I think it really goes a long way in the kind of subconscious, almost like timbre or something of the impression that you get when you're looking at the image. So let's do another matte on that note. And here what we're going to do is grab the feedback again with our select. But here I'm going to add the last matte into my top. Going to select my last matte, actually. So now I'm taking matte 1, matte 2. And I'll use this feedback, but I said it's luminance. But I don't necessarily want to use just the raw selected feedback, so I'm going to throw a threshold down, and that will allow us to do some softening and really fine-tune how much we want this matte to kind of be sampling from each. So maybe a softness around 0.5 is pretty good. And for the threshold, this is going to change depending on what your image is, right? Because very bright images are going to have brighter overall pixels, so the threshold will need to be higher, darker ones, lower, etc. So an interesting way to make that procedural would be to drop a resolution down. We're going to downscale our texture by a lot, as much as possible. So we'll set it to 1/8. So our resolution goes from 1700 by 2600 to 200 by 300. We'll analyze that top. And the reason we want to reduce the resolution before we analyze is just to make our computation costs a lot less. We will then top to chop it and grab this R value for our threshold. And this way, our threshold will be the average of whatever our image is. So we're basically just going to say whatever is above average, we're going to pull from our matte 2, and whatever is below average, we'll pull from matte 1. The way that I think about this is if matte 1 is using this noise to select between our image 1 and image 2, and matte 2 is using a separate noise to select between a feedback and the output of our first matte, we're really selectively ignoring the impact of matte 2 by using this matte 3 in a select statement. So we're saying wherever the threshold of our feedback top is above a certain area, we are going to actually ignore the operation of this last matte and just replace that pixel with the output of the matte before. So I hope that made sense. Essentially, we are adding layers using these two mattes, and then we're subtracting some of what we added using this other threshold. This is also why I'm using a feedback with a threshold for it instead of just another noise, because I want to do that final subtraction based on something that's a little bit more tied to our output, and not just like a procedural noise top. So we'll wire that in to our update texture and turn this off. And now we can really start to see some of the details and dynamism coming out in a pretty cool way. So I think the last thing that I wanted to do on our update texture is you can kind of see like right here and a couple other places it will pop up. It's kind of happening right here. The base image will come through and it will be a little bit too sharp. And that's the second base image, the update texture. Will come through and it'll just be a little bit sharp. I don't really like that. So I'm going to go back to the top of our matte waterfall. And I'm actually going to add something right here that will give us a little bit more variety. And so what I'm going to do is actually yeah, that's what I'm going to do. I'm going to copy and paste this. I'm going to collapse it. Come over here. We will allow these to both be... Oh, actually, no. Okay, so that's what I'm going to do. And that's the difference here. So I want to use this. This is going to be just like a simple pixel sort. So I'm actually going to get rid of that base weight. I don't want that. I don't need my velocity either, actually. I'll edit this. And so all we're going to do here is just strip out everything that's not our normal pixel sort. So I'm going to get rid of this that I added. And I'm going to get rid of this, and then I'm going to get rid of that. And then finally, I'm going to just set my sort direction manually. So I'm just going to say in sort direction equals 0, and then take out this preprocess directive. And then I think I'll just need to get rid of these. I'm just going to turn off all these because I don't actually care. I just want this to be a very simple pixel sort. And then the last thing I'll need to do is throw down a feedback. And that should, I hope, get things going here. And then what's happening now is because I'm selecting this other feedback, the feedback from one level up, things are getting weird. So I actually just need to pipe in our unfed back image. And so now we are starting to see a little bit of what we expect. Okay, I'm actually just going to get rid of all of this here and just hard code in our horizontal sort direction. What am I missing? Well, that could be it. Make our threshold 0, and now we can see the sort occurring as expected. So just to make sure we're all good. Okay, and then I think just instead of making it vertical or it's horizontal, I'm just going to switch it to vertical because I like it more. And then the last thing we got to do is just wire this feedback up to our parameter. Nice. Cool. So now we have a pixel sort coming out. I'm going to put another matte down. Matte. Down. wire the pixel sort into the second input, take our original noise here, make a copy, put that in the matte input, switch it to Luma, and yeah, see? Now things are starting to look pretty cool. So switch that to Luma. I'm going to switch the seed of this noise for sure. Maybe drop the period a little bit, play with the exponent. We do want to make sure that we're not changing the amplitude or offset for these matte noises because they need to be from 0 to 1, and we want them to be 0 centered so that things are smooth. Cool. So now if we reset everything and just hit play, things are definitely looking more interesting. If our update weight, I think it does need to be a little higher, maybe like 0.05. You can see some of this kind of drifting upwards from this pixel sort, while there's just a lot of other kind of evolution going on. We're getting pretty close to wrapping things up, but there are a couple final things that I want to toggle. So one is going to be parameterizing this noise exponent, because you saw the exponents really can change sharpness. So I'm going to use that exponent, and I'm just going to paste it on our other 3 noises because I'm going to use the same one for all of them. So now, by using this exponent slider, we can kind of change like how severe our matte cutoffs are, which you can use to your taste. Reminder, we can always still just change our baseline sort direction for some other effects, and that our sort threshold is also still working, which kind of actually looks really cool when you overlay it with these other effects that we have. So something else to explore there. Now, last major change that we want to make is changing the step size that we're going to be sorting on. So if you remember from last time, we were sorting just on one specific step size. And by that, I mean that our texel size is just equal to 1 over resolution in each direction. So that's just the width of a pixel. Now, if we were to change that, and maybe if I go over here, if we were to change that and make it 20 times the width of a pixel, maybe that's not working. Edit this again. Yeah. Cool. So if we make it 20 times the width of a pixel, we can see that there are more kind of jumpy, stuttered, textural things happening, which actually does look kind of cool just as is. But again, the whole thing that I want to do here is have different variations across the image. So we're going to, again, look up this from a lookup table, or a lookup texture, rather. So because this is going to be a lookup texture, what's the best way to do this? Maybe close. We're going to do this with a lookup texture. And so we're already using one top for just one channel. That's our base or our update weight. This is just going to be one channel lookup too. So I'm going to actually just pack this channel into the same texture and reorganize things a little bit just to keep things as optimal as possible. And the other thing is that we're only reading in 2 values from our velocity. So I'm actually just going to repurpose this velocity texture to have 4 separate layers, 2 of which will be velocity, 1 will be our update weight, and the other will be step size. So first things first, I'm going to rename this as data. So vec for data is going to equal texture std2d inputs, input 1, since that's where our noise texture is coming from, and we're going to grab everything. Now our vec2 stepdir will be equal to data.rg, read velocity text, so that's all working. Now we just need to get our other textures, our update weight, and our step size into the same texture. So to do that, we'll use a reorder. We'll pipe our velocity into 1. We'll say input 1 R, input 1 green. Then we'll take the output of our update weight, input 2 red, assign that to the blue channel, and then we will copy and paste these. Again, making sure to change our seed every time we do this. Take our noise. Okay, so now we're going to get rid of the transform, and we want our step size to go something like 1 to 20. So we'll take our math, we'll get rid of this multiply, we'll make the range go from 1 to 20, and we'll view normalized here. We can see that's not actually working because the normalized view, by opening a viewport and pressing N, is showing just all 1s. The reason for that is because we're still in 8-bit, but to go higher than 1, we need to be in 32-bit. So once we update that, we can see that we now have step size going from 2 to 20, 1 to 20. I'm just going to basically reset this to default parameters except for our period, which I'll put at 3.5. Then we'll wire this in to input 3 of the reorder, and we'll set this to our alpha channel. Now, I'll just Alt-N, and I'm going to call this data. And I'll change this to select data instead of select velocity, since velocity is just part of our data now. And we'll get rid of this base weight altogether. So now we can say float update weight equals data dot B, right? Blue channel holds update map, update weight map, and then last but not least, our float step size is going to be equal to data.a. Then we can just multiply this by our step size. We can go down here and get rid of our update weight altogether. And now everything is pretty much working. And we can see that, for example, if I pause it, like here and here, we can see our larger step size coming into effect and leading to some of this cool like texturing in pockets. different places. Plus, now we have the ability to change what that maximum step size is just using this math range. So we can customize the parent component, say max step size, and I don't know, maybe I'll default that to something like 20. Give it a range of 1 to 50. And then we can just assign that to our range. Boom. Just like that. So yeah, things are already looking pretty good. I'm going to throw a little bit of post in here. Level. And just go down with the brightness a little bit. Gamma 0.8. Nice. Let me brightness back up to 1. Okay, so the last thing that I want to do is to be able to look up my sort direction based on a texture. So right now our sort directions are all just being based on our selection, which is fine. But one additional layer of complexity we can add is just toggling that sort direction based off of some lookup. And so the way that we want to do that is by using another input texture, and in this case, just using a simple conditional statement to decide which way we sort based on the input texture. So, to do that, we can first select our input texture. I'll use a noise for clarity at the beginning. Save. Noise for clarity at the beginning, and we can do something like this, and that would be sortdir is going to equal, since sortdir is a bool, we're going to use a conditional here, so that will be if our texture of std2d inputs input 3, sampling at our current pixel location, .r is greater than 0.5, sortdir is going to return true, otherwise it'll return false. And so that will determine our sort direction based on this logic. And we can see here that it's working. Our sort direction is going different ways depending on what value our lookup has. And that is interesting. For our actual texture, I want to use this threshold that we've been matting over, actually, which will result in some pretty interesting dynamics as things are changing. But another thing that you may want to be able to do is turn off whether we're looking up the sort direction or not, right? So just make it super easy. You can comment in and out like this, but I don't know, that's not super great. Doesn't really help you a ton in the broader scheme of things. So what we can do is add a parameter, say lookup sort direction, make that a toggle, and then simply add that to our define. Which is now throwing an error because we hard-coded in this one additional define clause, or whatever, in our insert. We hard-coded in the contents. What we can do to make this procedural is simply go to Python and use list comprehension. So we'll say, open bracket, in single quotes, define for I in range open parentheses, me.numRows, close parentheses, close bracket. And what that will do is create a list with a entry that is a string, hashtag define, for every element in the range 0 to me.numRows, which in this case is 2. So we have a list of 2 elements, and that is exactly what we need for our defines. So now we can uncomment this and use our hashtag if lookup sort direction equals 1. Then we want to do this. Otherwise, we don't want to do anything. And this will let us then use our parameters to toggle that sort direction lookup on and off. I think that about does it for our code change. So I'm going to get rid of my VS Code, maximize this, get this back. Okay, so that's pretty much the effect. There's a couple things you can do to clean things up. So for example, I mentioned that I want to have the noises translate at different times. So I'm going to go back through and just translate our noises at different rates. This is our velocity, so definitely needs to be translating in case we do ever use it for anything. So we can make that translate parent .par.time.eval, which again is the right way to do it, times 0.01 maybe. Use the parent parameter .eval to make sure that we're actually evaluating the last value, the last frame. And we're already doing that, so that's great. We can maybe collapse those, call this database. Yes, okay, and then I guess we'll have to go through and update all of these to parent 2. And I just really don't understand why that doesn't happen automatically at this point, but hey. Oh, right, and then the last thing that I mentioned that we would do is set the resolution. So I'm going to set this to custom. We can see that's a value of 9. If I set it to use input, it's a value of 0. So what I'll do, I'll set it to custom. I'll make this 1920 by 1280. Customize my parent component, drop my resolution on there, set the reference, and then I'm going to create another parameter that is res from input. Make this a toggle, and then open up a parameter so we can see it. So what we want is when we toggle this to have our resolution change. So we want it to say use input when this is toggled to on, and we want it to say custom and use our parameter resolution when it is set to off. So to do that, we can use some Python again. We will say this is a inline conditional statement in Python, which is super handy to use for setting parameters. So 1, if parent .par.res from input .eval equals, so now we want it to say, oops, sorry, we want it to be 0 if our parameter equals 1, else we want it to be 9. Parent. Cool. So now we can see as we toggle this that we switch from input to custom resolution, and then our custom resolution is based on the input parameter, which is ideal. So with that, I think I will leave things here today. There's obviously a ton of extensions you can take. You know, changing this mat, you can already see changes things quite a bit. Using the threshold in conjunction with the exponents and the mat is looking pretty interesting. You can look up the sort direction from the input while using these other parameters. So there's, like I said, many different ways to take this in a lot of your individual directions. Let me know as people have cool ideas and come up with some stuff. I would love to see it. And yeah, thank you to everyone who's supporting me on Patreon. As I've said before, it really means a ton and allows me to do a lot more of this than I otherwise would be able to. So I really appreciate it. Thank you all for your support. And if you guys are enjoying this, make sure to like and subscribe below. Until next time.